Okay, so our goal in this talk is to talk about data. And what do we mean by it? What does it look like? And how can we essentially get an idea of what the difference between a variable, a participant is, and some other terms that we're going to introduce. This is going to set the stage for actually performing data analyses. To do analysis, we need data. And to do the analysis well, we need to get a specific understanding of what our data looks like and what are some of the characteristics of it. The data that we're oftentimes going to be working with, and there's a large number of data types, is we're going to refer to this as survey data. Survey data is most often of the sort where we ask individuals questions and then we code their responses. Oftentimes they can be answering questions in the format of not at all like me or very much like me. Then we're going to take that response and turn it into some numerical value. As you can see here, we have a large number of numerical values in this data set. Specifically, we're working in a spreadsheet, and we're going to take a look at the individual responses and what variables are we working with. So in most data sets, we're going to represent them in a wide format. A wide format means that we have variables on the columns. So these correspond to each of the individual questions. And each row corresponds to a specific individual. In a long format data, each individual could be represented multiple times. In a wide format, each row is a single person and they are not duplicated. Each row is somebody unique and we don't see any, again, copies or duplicates across the rows. Oftentimes we don't have identifiable information in our data set. So we don't ask people their names. We don't code them in the actual data set. Also, sometimes we don't include date of birth. We may just include age. Again, our goal here is not to identify individuals. Our goal is to make statements about the population or about people at large. So in the spreadsheet, we can see that we have our variable names or our column names right here. And then each row corresponds to an individual's responses to each of those variables. Each of those variables, again, is a specific question that we may be asking them. So person number 1 responded with a 2 to gender. Person number 1 also responded with a 2 to Hispanic, 2 to race, 5 to military, etc. What these individual codes mean, same thing with what the variable names are or the column names are going to be coded in what's often termed a data dictionary. It's easiest to leave things in a numerical format and to have shorthand for the variable names. And then we have a data dictionary, which gives us more information. So we can look up, what does BHSDP lowercase c actually mean? So with this, we can see in individual responses and on a large number of variables. We can see as we move further and further right in the spreadsheet, there's more and more variables, which means more and more questions. And as we move further down the spreadsheet, we can see all the individuals' different responses. So these correspond to different people. With this, we can go way over and start scrolling down and see that we're getting into the 200s, 300s, and so on and so forth. It's quite unwieldy to get an idea of what's going on in the data by actually looking at the spreadsheet when we're working with large data sets. In machine learning, we're almost always working with large data sets, meaning that we have more than a few variables or columns, and we have more than, say, 20 individuals. Here we have a number of individuals in the thousands and greater than 100 variables. This, again, makes it essentially too much to get an idea of what's going on in the data. So what we're going to do is we're going to move to using a programming language or a piece of statistical software to summarize the data for us. Again, if we were working with a very small data set, we could get an idea of what individual responses are on the individual variables or individual columns. If we had less than, say, 10 variables and less than 100 people. But again, it's hard to summarize things in this format. So what we're going to do is we're going to select individual columns or variables from this data set, and these are going to be put into our statistical program. In the next talk, we're going to talk about differentiating between what an outcome variable is and what predictor variables we're going to be using. Again, a predictor and an outcome, or predictors and an outcome, all correspond to the individual columns in our data set.